Hi everyone, today I'm going to teach you about uniform motion and how you can answer uniform motion questions using this equation. Let's start by answering the question, what is uniform motion? Uniform motion is motion with no acceleration. That means the object is moving with a constant velocity. So the object is not speeding up, it's not slowing down, and it's not changing direction. For example, a car that's traveling east and it's going 30 kilometers an hour. If the car does not speed up, does not slow down, and does not change direction, it's moving with uniform motion. Now I just described uniform motion as motion with a constant velocity. But what is velocity? Well, velocity is an object's change in position over time. And that's where the velocity equation came from. V is equal to delta x divided by delta t. This tells us that an object's velocity is equal to its change in position divided by the time it took to change its position. And now velocity is a vector quantity. We know that vectors have both magnitude and direction. The magnitude of velocity is the object's speed, and the direction is just the direction that the object is traveling. But this brings me to a very important point. When you're answering questions with velocity, you have to have the correct sign. So for objects that are moving to the right, the velocity is positive. For objects that are moving to the left, the velocity is negative. For objects that are moving up, the velocity is positive. And for objects that are moving down, the velocity is negative. The sign of the velocity vectors matters because it describes the direction that the object is moving. And so now that we understand uniform motion and what velocity is, let's take a look at the equations you'll need to answer uniform motion questions. What's great about uniform motion is that you only need one equation, which is your velocity equation. This says v is equal to delta x divided by delta t. V is the velocity of the object. Delta x is the object's change in position, and delta t is the time it took for the object to change position. Now, even though this is the only equation you'll need, let's make a quick substitution so I can show you a different variation of this equation. We know that delta x is equal to the final position minus the initial position. So that means we can substitute delta x for xf minus xi. Then we can rearrange and isolate for xf, the object's final position. And that gets us this equation, which says xf is equal to xi plus v delta t. This is just another way to represent our velocity equation, and I find it very helpful for answering questions. Now let's dive into 3 different questions to practice using our velocity equation. For our first question, we have a car which is moving with a constant velocity of 10 meters per second. And we want to know how long will it take to go 25 meters. Since we were told that the car is moving with a constant velocity, we can use our velocity equation, which says v is equal to delta x divided by delta t. All we need to do is rearrange and isolate for delta t. And then we can plug in our values for delta x and v. And when we do the math, we can see that delta t is equal to 2.5 seconds. This means it would take the car 2.5 seconds to travel 25 meters. Now that was a pretty easy question. Let's try one that's a little bit more challenging. Here we have 2 cars which are 150 kilometers apart, and they're traveling with constant velocities in opposite directions. We're told that the red car is traveling with a velocity of 80 kilometers an hour and it's headed east, while the orange car is traveling west. And now if the 2 cars pass each other after 1 hour, what was the orange car's velocity? Now what makes this question more difficult is that we're working with 2 objects. So notice how I use subscripts to differentiate between the variables for the red car and the orange car. And now there's 2 very important things that you have to recognize in order to answer this question. The first is that when the cars pass each other, they will be in the same position. So we can say that the final position of the red car will be equal to the final position of the orange car. The next important thing is that you recognize that the initial position of the red car is 0 kilometers and the initial position of the orange car is 150 kilometers. I know this because the two cars have to be 150 kilometers apart. Now, in order to answer this question, you're going to have to set up two equations, one for the red car and one for the orange car. And we're going to use our xf is equal to xi plus v delta t equation. Make sure you use the correct subscripts so you can differentiate between the red car and the orange car. And now we already know that when the cars pass each other, they will be in the same position. So the final position of the red car is going to equal the final position of the orange car. And now what this means is I can take the equation for the red car and set it equal to the equation for the orange car. And now we were asked to solve for the orange car's velocity. That means I need to rearrange this equation to isolate for VO. And once we've done that, all we need to do is plug in our values. And when we do the math, we can see that the orange car's velocity is negative 70 kilometers an hour. Now I want you to ask yourself, does it make sense that our answer is negative? And the answer is yes. The orange car is traveling west, which means its velocity vector would be pointed to the left. And we know velocity vectors that are pointed to the left are given a negative value. And now let's do one last practice problem. Here we have two cars that are traveling at a constant velocity. The red car is traveling at 25 meters per second, and the orange car is traveling at 15 meters per second. And if the orange car is 10 meters ahead of the red car, we want to know how long will it take for the red car to pass the orange car. Now this is very similar to the question we just did. You have to be able to recognize that when the cars pass each other, they will be in the same position. So the final position of the red car will be equal to the final position of the orange car. You also have to be able to recognize that the initial position of the red car is 0 meters, and the initial position of the orange car is 10 meters. And that's because the orange car is 10 meters ahead of the red car. And now because we're dealing with two objects, we're going to set up two equations using our xf is equal to xi plus v delta t equation. We have one for the red car and we have another for the orange car. And now we know that when the cars pass each other, they're going to be in the same position. And this means we can take our equation for the red car and set it equal to the equation for the orange car. And now this time we were asked, how long will it take for the red car to pass the orange car? That means we need to solve for delta t. So all we need to do is take our equation and rearrange for delta t. And once we're done that, we can plug in our values. And when we do the math, we can see that delta t is equal to 1 second. That means it would take the red car 1 second to pass the orange car. And so that's how you use the velocity equation to answer questions about objects moving with uniform motion. Now the last topic that I want to cover is position versus time graphs for objects moving with a constant velocity. Now for a position versus time graph, your x-axis will have time and your y-axis will have position. And now if we're dealing with an object that's moving with a constant velocity, it will have a linear position versus time graph. And now one of the most important things about position versus time graphs is that you can find an object's velocity from the slope of a position versus time graph. Do you remember the equations for finding the slope of a line? Well, you can find 2 points on the line and then do y2 minus y1 divided by x2 minus x1, or you can take the rise divided by the run. And now let's use what we learned to analyze this position versus time graph. The first question is, what is the object's velocity for the first 3 seconds? That means we're looking at this part of the graph. And in order to find the velocity, we just need to find the slope. I'm going to use the y2 minus y1 divided by x2 minus x1 equation. All I need to do is find 2 points on the line and then plug in my values. And when we do the math, we can see that the slope of the line is 2 meters per second. That means the object's velocity is 2 meters per second. The next question is, what direction is the object moving from t is equal to 3 seconds to t is equal to 6 seconds? That means we're looking at this part of the graph, and I can tell you that the object is moving left. Now the way I knew this was because the slope of the line is negative. That would give a negative velocity. And we know a negative velocity means the object is moving to the left. And finally, we want to know what is the velocity for the last 2 seconds. And that means we're looking at this part of the graph. And I can tell you the velocity is 0. And I know that because this part of the graph is a horizontal line. And a horizontal line has a slope of 0. So in other words, the object is not moving. So it has no velocity for the last 2 seconds. And so that's how you can analyze a position versus time graph for an object that's moving with a constant velocity. And with that, that's the end of this lesson on uniform motion and how you can answer uniform motion questions. Thanks for listening and have a great day.